I'm Tony. Welcome. Today we're going to control a bipolar stepper motor with TinyGo. What you're looking at here is the project's README file. It contains everything that you need to know. Links to this project and this README are included in the video description below. It describes the components that we use. Of course, the NEMA 17 stepper motor is the star of the show today. Before we jump into the code and look at the wiring diagram, let's first take a look at a simple animation so that we can understand what we'll be doing today. To help understand what we'll be doing, imagine the rotation of the stepper motor being like the hand of our hand of a clock. What we're going to do is rotate that hand from 12 o'clock onto 3 o'clock and then back. Now this takes a quarter of a rotation. When it's done with that, it'll go all the way to 6 o'clock and back, and this is a half rotation. Lastly, it goes all the way to 9 and back, and that's a 3/4 rotation. Now, based on the specs of the motor, it takes 200 steps to make one full revolution. So a quarter of rotation is 50 steps. Half of a rotation, 100 steps. 3/4 is 150. So if we add up all the steps traveled clockwise, double that, that's the number of steps going back. If we add all that up, and it's displayed over here, you'll see that we're going to travel a total of 600 steps. So the easy stepper driver allows you to set the rotations per minute of your motor. So we're going to set the rotation to be 3 rotations per minute. That's 200 steps per minute, 3 rotations per minute, that's 600 steps per minute. And as we saw before, if we add all the rotation up, we get 600 total steps. So this entire demonstration should take in real time a minute to complete. So that'll be a good check on our work. Let's take a look at how we have our components wired together. So here on the right is the ESP32 dev board. In the center we have our motor driver. At the top, this is a motor kind of from the side. This is the shaft facing up. And down below we have a separate 5-volt power source. Now the first thing is, let's look at the motor. I am not going to do a good job explaining the stepper motor. I have a reference down below, as you can see here. DroneBot Workshop, if you haven't seen his YouTube video or read his article, it's great. He uses Arduino, so here what you're going to see that's new is using Golang and TinyGo. But he does an excellent job explaining bipolar stepper motors, unipolar stepper motors, and so forth. All I'll say is that if I look at the specs for this, we see that these are the terminals for the red wire goes to positive of the B coil, and the blue goes to the negative of the blue coil. And then the A coil, positive, negative. And what we do is we take the output on the motor driver, out 1 and out 2, and run that to the first coil, coil A. And we run the second output over to the second coil. The power, down below on the left, we have our power source, so we run the positive directly to the, this VMS is what you use to drive the power of the motor. And that should be separate from the 5 volts that powers the logic on the stepper motor board. So in this setup, we're going to power the logic board on the motor driver from the ESP32. So the 5 volts from the ESP32 dev board is wired to the 5 volts on the driver board. In this configuration, we should remove the 5-volt pin to indicate that the power is coming from a separate source. The motor and logic board are separate. We tie all the grounds together, so the negative on the external power source and the negative on our dev board is the same. Lastly, we make sure that the enable pins for motor 1 and motor 2 are on. That's on the far left and right. And then we have 3 inputs.
Correction, that's 4
1,
inputs.
2, and 3. And I just arbitrarily picked some pins to use for this. So pin 32, 33, 25, and 26. So I just went in numerical sequence. No magic to it. So before we actually run the demonstration, I wanted to give you a look of the actual components, not just my drawing of them. Hopefully that'll make more sense. On the right, I have my component reference. I try to keep a reference of all the components that I use. I have a link to that in the video description. So here's the ESP32 board I'm using, and you can see all the breakout pins. Next, let's go take a look at the motor driver. So here's what it looks like on the left. The blue breakouts on the left and the right are for the out 1 and 2, out 3 and 4. The 3 connections at the bottom with the blue is the BMS ground and plus 5 volts. To the right of that, you see the enable pins are on and the motors are enabled. And we have input pin 1, 2, 3, and 4. Also, right here is the onboard 5 volt. Here it's showed as enabled, but I pull this off, and it's not enabled when I run this exercise. And I believe that's it for that. Lastly, here's the stepper motor I'm using. Here's a better picture of it, and as you can see, it's really hard to see, but the color is red. I think it's black, blue, and green. Now, when I look up the reference for this, it had 2 wiring diagrams, and I believe I'm using wiring diagram 2, which is the black. It works, so it's wiring diagram 2. That's how I knew which one was A and which one was B. Okay, let's take a look at the code, and then we'll watch it in action. This is a simple program. You see on the left, there's only one source file, main.go. I think we've seen these before in previous videos, machine, time, and format. The thing of interest here is the use of the TinyGo's Easy Stepper driver. The first thing we see are the 4 pins that we've defined. And if I hop over real quick again, those 4 pins are these pins on the board. Then we configure those for output because we want to drive the input on the motor. This variable here I use to hold the variable that says that this motor, this specific NEMA 17, this particular brand, can go 200 steps per minute, 200 steps per rotation, I'm sorry. I have a comment here that explains how, there we go, how the demo will work. We've already been over that, but needless to say, we're going to watch the motor spin. It's going to go through a total of 600 steps, and we hope that takes 1 minute. To ensure that, you see here's where we set the rotational speed of the motor. So we're setting it at 3 so that it takes a minute. If I had more time, I would set it higher and see that it, set it at 6 and see that it takes less time. All right, let's create an instance of the Easy Stepper. We give it the pins that we're using. We tell it the spins per rotation that our motor is capable of and what speed we want. we call this configuration, which sets things up, and then we're ready to go. So the next thing that happens is we just go through and we say, I print a few things out to the console and keep track of the time so that we can see how long it takes, and you'll see that in a minute. But we go to 3 o'clock by moving forward 50 steps, and then we come back to 12 by moving back negative 50 steps. Then we move a half turn by moving 100 steps, and we move back by moving negative 100 steps. Same with 9 o'clock. Forward 150 steps, back 150 steps. Then we see how long it took and print out the duration, and that'll be a check, and we should see that it takes a minute. All right, let's load this on to our board. I already have the command in my buffer, so the command is TinyGo flash. I tell it what target, and if I forget what the target is, I can look at the bottom here and see what board I have picked. In my case, I have several ports, so I actually had to specify the port. I would try it without the port. Most of the time, it will find it without you specifying it. Okay, I'm going to flash the board. So here is a live picture of the board. Down below, I'm going to flash. Now I got to press the button in order for it to take. All right, that's good. You'll notice here I have a mark on the motor so that we know that that's 12 o'clock. That's the hand of the clock. And it will rotate. Let's just turn it on and see. Before we do that, I am going to bring up my serial port monitor, PicoMon. I'm going to set it at the default baud rate and use the same port, device port. So let's do that. We're ready to go. So I have a pause at the beginning so I can get things set up. Oh, let me turn the power on. Hold on. Let me reset this. Reset button. There's a little pause at the beginning, so I have time to get it set up. That's why I did that. All right. If we look down below, Schoolhouse Rock, start, 369. Right now it's going to 3 o'clock. Now if it looks a little bit off, you notice that the motor is actually turning and spinning. I don't have it mounted solid, so it might be off a little bit, but it's accurate. All right, just went to 6 o'clock. We're coming back. All right, for the grand finale, we're going to go all the way to 9 o'clock. And back. And when it's done, and it's at 12 o'clock, it'll pause for a second, and it'll display how long it took, and we should see that it takes a minute. All right, so you see the duration down there is 1 minute and 0.005 seconds. So I think I'm going to call that a minute. And I think that's a successful demonstration.